So let's go over lesson 2.6 together, proving angles congruent. Now the first blank talks about a definition of a proof. A proof is a statement that you prove using deductive reasoning. So within your proof, guys, you're allowed to use anything that you've already been taught. So that can include any definition, properties, postulates, theorems, and every single proof will start with me giving you information to start it. So this probably makes no sense. It will by the time we're finished. So let's just jump in. So understanding the problem. The most important step in proving something is realizing what is given to you. So let's write that in. What is given? And what has to be proved? What is to be proved? So, you have to know what's going on. That you have to know what information you're starting with and where you're supposed to be when you're finished. So, a couple questions as you move along. The first one is, why is this so? So when you're moving through a proof, you do a step and then you have to justify that step. And again, we're going to talk about this more as we get down through the notes. And the other thing we have to ask as you move through a proof, is there any way this could be false? So let's write, is there any way? Let's just write that. Is there any way this can be false? All right, so we're going to make sure we do our proof step by step. And let's see, we're going to remember the definitions you were given, take times to ponder the proof. Okay, so guys, the whole entire point of geometry is to learn deductive reasoning. We're learning how to think logically. I know when you leave my class, you're not going to do proofs out in the real world. Guys, it's about the learning. It's about learning to use your brain. So, the goal isn't the proof. It's about learning. So, it's about learning. It's thinking at a higher level. Okay, so the first thing we're going to talk about is solving for x. Now, somewhere on here, let me find it. I'm going to jump to right here. We have the vertical angle theorem. And the vertical angle theorem tells us when you have vertical angles, they are congruent with each other. So, knowing that, let's go back up to number 1. And we have a set of vertical angles right here. We know vertical angles are equal. So to solve this, all you have to do is take 68 minus x and set it equal to 3x. So let's grab a calculator and solve this. So I'm going to add x to both sides. 68 equals 4x. And then divide by 4. So 68 divided by 4 is 17. Now the directions say, then find the measure of each angle. So how do you do that? All you have to do is plug it back in, and you should get the same answer. So let's try the left side. 68 minus 17, that's a 7. 17 should be the same thing as 3 times 17. So let's try it. 68 minus 17, and I'm typing it in on my calculator. I get 51. 3 times 17. Again, I just used a calculator, and I get 51. So I solved for the variable, and I found the measure of each angle. All right, so I know there are a lot of these, and I'm going to skip a few because I think you guys get the idea of it, but we're going to do a few of them together. For instance, let's do number 2 and skip number 3 because they're very much the same. When you go to do this problem, we're going to use the vertical angle theorem and prove that the top and bottom are vertical angles and that they are equal. So 10x minus 18 equals 8x plus 14. So to solve for x, let's subtract 8x. So 2x minus 18 equals 14. And let's add 18 to both sides. So 14 plus 18 is 32. And I'm going to move my work over here to the right. 2x equals 32, and x is 16. So are we finished? And we're not, because you have to plug it back in. So when we plug it back in, we should get the same answer for both of the vertical angles. So let's try it. 10 times 16 minus 18. So that's 160 minus 18, which is 142. So let's try the other one. 8 times 16 plus 14. So let's grab a calculator. 8 times 16 is 128. Add 14 to that, and I get 142. So it worked. So I know it's correct. Now, we still have to find this little x. So we're going to use some old information. For instance, don't we know that we have a linear pair? So I'm changing color. This is a straight line. And for instance, we have a linear pair here. We know the little angle plus the little angle equals the big angle, which is 180. So to find y, I'm simply going to take 180 and subtract 142 from it. 180 minus 142 is 38. And I should make that equals y. All right, so we're done. Now, moving on to number 4, we need a way to figure this out. And there are 2 ways to do it. You could set it up, say, hey, vertical angles are equal. And that would work. And you could solve for x. Or we could back that up a little bit. And we could say this little angle plus the next little angle equals this straight line. So this is a linear pair. And so the 2 together equal 180. So guys, I mean, it's up to you how you want to do it. I say since we're doing the vertical angle thing, we can do that. But just note, we can do it either way. And for time's sake, I'm not going to show you both ways. So let's subtract 9x. You're left with 2 equals x minus 12. Add 12 to both sides. 14 equals x. Okay, now, I do believe the directions say, let's go back and look, find the measure of each angle. Okay, so now that we know x, we have to plug it back in. Okay, so changing color, I thought, let's see, 9 times 14 plus 2. So 9 times 14 is 126. Plus 2 is 128. All right, so we should get 128 for its vertical angle. Let's try it. 10 times 14 minus 12, so it's 140 minus 12. So let's type it in and verify, and you get 128. Good. So that means we're correct. So how do you get the angle of, here I'm doing it in blue, how do you get this angle? So there's 2 ways. You could either plug x back in and work it out, or we could take 180 and just subtract 128. So when we do that, we get 52. Okay, so number 5, I am going to skip because it's just another vertical angle and we did a bunch of those. Okay, so here's where the fun begins. We get to do these proofs. And at first they are a little tricky, but I will walk you through them and they are easy by the time we're finished. So if you notice up here, there's something called a given statement, and that's what we start with. You have to have some information to begin with. So you just go straight across, and you're going to say, hey, this information was told to me. This is given. Now, there's also something down here called the prove statement. Now, here's a big mistake. You do not write prove down here. No. What we're going to do is you're going to show me how do you get to that step. But we know that green last step down here is our final goal. So we know the purpose of the proof. We know we're trying to get to angle 2 is congruent to angle 3. So let's look at step number 2. Now, it says angle 4 is congruent to angle 2. So I'm going to look at the picture and I see that angle 4 and angle 2 are congruent. And how do I know that? Because when I look at the picture, they're vertical angles. Now, when you see the vertical angle theorem, we can write out the words vertical angle theorem. But as you guys know, a lot of times mathematicians are a little bit lazy and, we're time efficient. So another way of writing vertical angle theorem is just to abbreviate it, VAT. Now, if you hate that, feel free to write it out. Vertical angle theorem. Okay, so I can tell you as we go through, I will start abbreviating VAT. Okay, so we have that step. We took this step and we justified it here. Now, when you look at step number 3, angle 1, let's go to the picture. Angle 1 and angle 2 are congruent. How do we know that? They're not vertical. So we have to come up with a way to know that. So we're going to look at the previous steps. Okay, so just bear with me here. So in step number 1 and step number 2, we need a way to come up with step number 3. So in step number 1, we had angle 1. And in step number 2, we have an angle 2. So I want you guys to notice something. And I'm going to erase this yellow there. So angle 1 and step 1 and step 2, they both have something in common. They both have angle 4 in common. So since they both have that angle in common, that's a property. And this is a property from the previous lesson. So we have to go back and look at the list of all the properties. So try to guess. So guys, we're going from step 2 to step 3, and the reasoning goes straight across. The reasoning is called the transitive property. And the transitive property always works when both steps have something in common, kind of like just like the force, and then you're left with angle 2 is congruent to angle 1, or angle 1 is congruent to angle 2, either way. So you're finished with that step. Now, moving on to step number 4, it says angle 1 is congruent to angle 3. Now, guys, I know these numbers start just looking the same after a while, but you have to push through it and look at the picture and say, do we know this already? Angle 1 and angle 3. So let's look. Angle 1 and angle 3, how do we know those are congruent? Well, we've already had this step. How do we know those are congruent? What kind of angles are they? They are vertical angles. So again, I'm going straight across. And for step number 4, I'm writing VAT for vertical angle theorem. Now, for your last step, again, let's look at the picture. You're trying to prove that angle 2 and angle 3 are congruent. How can you do that? So I'm going to tell you, guys, it's all about previous steps. Can you find it in previous steps? And you can. So I'm going to erase some of this stuff so you can see it with ease. So in step number 4, do you have an angle 3? Sure. In step number 5, do you have an angle 3? Sure. Now, where do you see this angle 2? Hopefully you're seeing that in step number 3. Now, what do you notice that angle, step 3 and step 4 have? They both have angle 1 in common. So since they both have the angle 1 in common, we can say, we're doing the transitive property again. Since they both have it in common, we can do the transitive. And prove it. So, things that you should have learned during this proof. 1, you always start with given. So right here, guys, boom, did you start with given? Lastly, for the last step, you never ever write the word prove or finished or done. You also learned that you have to fill in every blank. You have to always look at the picture. And if the picture doesn't help you, you have to look back at previous steps. Okay, so I'm trying to teach you how to do these, and they are sometimes kind of scary, but we have to work our way through them, and you will get good at them. So, for example, number 2, from Q to S. Now, guys, I'm going to mark my picture up, and I expect you to mark your picture. From Q to S is 42. From Q to R is X plus 3. And from R to S is 2X. Okay, so we have our picture all marked up. Now, we have to prove this. What are we trying to prove? Well, you might say, how do I know? Well, look right there. It says prove. What are we supposed to do? This is our goal. So this goes down here in step number 4. So we already know what we're proving. Now, can you write prove or done or finished here? And hopefully you're saying no. All right, so how did I know step number 1? How do I know all this information? It's a G word. What is it? Given. Now, they're giving you hints. Notice this is segment, addition, postulate. So if you don't remember that, you're going to have to go back to chapter 1 notes and look it up. This is where we dealt with segments, and we said little segment plus little segment equals big segment. So you have to write an equation. So let's try this. X plus 3 plus 2x equals 42. All right, so next we are going to try to solve this. And I don't know that I agree with the next step. Okay, now if I were solving this, what I would tell you to do is group all your terms together. So if I add x and 2x, I get 3x. So guys, I'm going to add a step. You know what? This is why I messed up. I thought step number 4 was the last step. If you look, see, there are more steps here. I'm sorry if I led you astray. This is what happens when I download my notes to OneNote. I don't realize there's more. Okay, this proof statement, guys, down, 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 down to right here. So it is x is 13. I knew it didn't seem right. Okay, so anyhow, I'm going to say I need to fix this before I give you the notes in class. This step should be simplify or combining like terms. I don't care. You can say either one. We're doing the same thing, combining like terms. Because aren't we just adding x and 2x to get 3x? And we are. So you can use the word simplify, or you could say combining like terms. But that's what that step should be. For step number 4, you're going to take the 3 to the other side. Now, guys, you're really not supposed to show like the work. You're just supposed to produce the step. So, like in your head, how do you move this 3 over? Well, you subtract it. So when I subtract it, That is a property. Okay, this is called the subtraction property. Now remember, do not write sub-prop, because if you just write sub, that could be substitution or subtraction. Now this proof is, it's missing a step, or I don't know what it's. I'm going to start over.